Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mountz, and I'm glad that you have taken the time to join us today as we look at our topic of, excuse me, ooh, I need some water here. Hold on a second. There we go. Enhancing manufacturing efficiencies with a screw counting process. And so, as we typically do when we start with our webinars, we'll highlight fastening challenges and quality issues that may be a result of poor manufacturing or risks that are actually in the fastening process. And the first one we'll highlight is going to be the human error that we typically can see when an operator is not necessarily paying attention to exactly what they're doing, and they can miss certain things or have errors occur that they don't necessarily hear about, or not hear about, but they don't necessarily will register with. And so let's talk about some of those errors. And over tightening is an issue that can happen in certain circumstances, and it's a really big issue because when we are using torque to generate the clamp force that's holding our components together, the fastener in there is designed to go to a certain amount of stretch, and if the fastener gets over tightened, it can then get close to its yield point and it can fail with any type of shock or vibration that can happen. And so over tightening is not necessarily good, or tighter is not necessarily better in the actual fastening process. And obviously the opposite of that would be an under torquing or under tightening type of fastening. Again, with any type of shock or vibration, it can cause that fastener to either back out or not hold the clamp force correctly. And again, we can have failure. So making sure that those two items are accounted for is what we're looking for. Some other errors that can happen are going to be cross-threading. That's going to happen right at the very beginning of a rundown. But if you have a small fastener or so, you may not necessarily be able to detect that. Or again, if the operator is not paying attention. But the tool will certainly torque out because it's going to go ahead and reach the torque value because the fastener then obviously is bound up. Then we have missing fasteners that the operator may not necessarily hit because, again, they're not necessarily paying attention or they think they did that. And so that's primarily what we're talking about doing that today with screw counting. So all of these different errors that happen can be detected through the use of a screw counting tool with error proofing capabilities. And basically what that means is that it gives us the ability to track each fastener as the tool or the operation is being used. It does detect if there is a fastening error, alerting the operator, giving the operator the opportunity to go ahead and attempt that fastening to make sure that all of the fasteners get torqued and that they get torqued correctly. And this helps, again, to remove the operator influence from neglect or not necessarily seeing or, again, not paying attention to the actual process within whatever the parameters might be for that particular fastening. The other things that we can help with are going to be being able to have line management. So it can assist in being able to do that if you have the scenario where you may be communicating with a line control device, those types of things. But if we look at some of the detectable errors that we can detect, this will help us to, again, be able to eliminate or safeguard against some of those potential failures that can happen, making sure that we get our fasteners torqued and that we're producing the correct clamp force for the application that we're trying to achieve. Now, the first one is going to be the difference in a fastener length. And so you could have all things being equal for that particular fastener except for the length. So we can go ahead and detect that. So we want to make sure we've got the correct fastener in there, not one that is either too short or too long. So if you do have that scenario, we would be able to detect that type of difference. Next is going to be if there's a difference in the actual thread pitch of the particular fastener. So maybe everything is the same except for the thread pitch. The operator grabs the wrong fastener from the bin, and the thread pitch will bind up, acting very much like a cross thread event. And we'll talk about that here in just a second. But you can also have fasteners that are unseated. So run down partially, but not fully engaged to the mating surface. We would be able to detect that as well. Errors if there is a washer stack or another componentry such as a gasket or a washer, we would be able to detect those types of fastening errors within the process. And then, as I mentioned, the cross-thread type of an event where that fastener will be get bound up near the beginning of the rundown, and the tool will reach torque, but the fastener is not creating any type of clamp load whatsoever for that particular application. You can also have a scenario where the bit may come out of the fastener and it is not fully seated. So you could have a couple different errors in one particular rundown. You could also have a stripped fastener. So a fastener that is not, again, because it's stripped, it's not creating any type of clamp force, but the operator may not necessarily see that or understand that that's happening. And then finally, you would have a number of combinations of different errors that could happen in a recessed or a blind type of fastening in a channel or something where the operator necessarily can't see, but they're just relying on making sure that or the tool shuts off, or we really can't determine whether that particular fastener was cross-threaded or if it was stripped, or certain other types of errors because they simply just can't see it within that recessed area. And so that's going to lead us to our poll question for today. If we go ahead and launch that, and the question is, what common fastening failures are you experiencing? So let's go ahead and give you a minute or so to go ahead and answer that, and we'll see what our results are here in just a minute. And I'll grab another drink of water. Thanks for that. All right. With that, that'll go ahead and we can end that poll. And it looks like stripped screws is the winner here, with cross thread and missing screws to follow up. So thank you very much for participating in that. And so as we look at being able to help detect these errors and the screw counting process and how that functions within that, let's go ahead and take a look at the different counting options that we have available. And so the first option that we have here is going to be our Scout 2 product. And this works at the use of a transformer style tool or STC30 and a standard clutch tool. There are a couple other variations of tools that we have that this product can work with as well. But this allows us to be able to monitor the amount of time it takes for a particular fastener to run down. And we're going to go ahead and we'll show this in our demo portion for today, how we program it, do it within the actual use of it, and we'll show you what that looks like for that particular fastening. But this particular option does allow you to have more than one fastener profile. So you can have up to 8 different fastener profiles that you can use. And then you can also use multiple tools as well within either one particular fastening or with a different program for that. So we'll show you what that looks like when we go to our demonstration for today. Next is going to be the use of a DC control tool. So in the Mountz case with our EC products or our EPT product, there are counting functions that are built in within that. So we can either do a global count setting for a particular application, or we can actually create a what would be called a model or an assembly process where there may be different presets that are needed within that assembly process. And the tool itself will count down through different presets. And then as it needs to change, it will automatically change to another preset and allows the operator to continue the operation of that particular assembly without having to change a preset or rely on a barcode scan or something else to go ahead and change that preset. And it is monitoring the amount of fasteners that are needed for that particular step and the overall application as well. So that is another option. If you do have a DC type control tool, that type of functionality may be in it. It certainly is with the Mountz DC type tools. Next is going to be a scenario where if you want to really be keyed in on error proofing for your assembly, and you not only want to scout or count the application, but you need to make sure that the operator follows a particular pattern. We could use our DPC Touch product with the actual tool, and that could be either a DC type tool or it could be a clutch type of tool like we're going to be showing today. But that system works off of a location type of system where it knows where the tool is in space, and it only provides power to the tool for the correct fastener that needs to be tightened in the assembly process. So the operator only has one location for the tool to actually work. So we can control the operator moving through a pattern for that particular assembly. Plus, if we're using it with a DC tool, we can also program in which preset is used for that particular location as well. And the system is only going to index to the next location if the tool provides a good rundown signal from the tool or the DC tool as well for that particular type of system. There is a visual aspect to this as well, where it's providing information on the target location for the operator to be able to move the tool into the correct location. And so this would be another counting option that, again, if you have a really critical type of application and you want to make sure that the operator is following a specific pattern, and you need to make sure that there's a 100% error proofing type of need, you would be able to implement that with the DPC Touch system. And so with that, that's going to lead us into our demo for today. And as I mentioned, we do have the Scout 2 product here. And this is the unit here. It is being powered currently right now through its connection to the transformer. But you could also use direct power here to the unit. Just to kind of go over what we're looking at. On the upper left here, these are the ports for being able to add different tools into a particular use case. So if you had 2 different tools, they were using the same fastener profile, then we could use those 2 tools within one particular program. So right now, this is showing program 1 that we are looking at. Here is going to be the display on if the fastening was okay, or if it was no good, or if the cycle was complete. These will go ahead and be an alert to the operator. There's also a buzzer mechanism that can be implemented for either just okay, just no good, or for both with a slightly different pattern to it. And then also a cycle complete buzzer to that. Up here is the display telling us how many fasteners we have remaining in a particular fastening profile. So this is alerting the operator on what number we are dealing with within the application itself. There is communication to this. There is software that is available for this to be able to program it, and that is available through an RS-232 port, or there is a USB port as well. We have our programming function buttons here, and then below that we have a 25-pin I/O, and then also another port for another style of tool that we can use as well. And so that is kind of what you're seeing here on the display. If I wanted to go to a different program, I can press the up button, and now we're dealing with program number 2, and so forth. In 3, we don't have anything set in. 4, 5, 6, or 7. As I mentioned, there are 8 different fastening profiles that you can use for this particular tool. Now, the way that this system works, as I mentioned, it works off of a time-based type of profile. So I have our a thread block here with some of our fasteners, and if I take the tool and I want to basically learn the profile of these fasteners here, well, we can do that by going into what would be the measuring mode for the unit. So the unit itself is password protected, so the operator can't necessarily go in and make any adjustments to it once it is set the way that you like it. The password is 0 upon receiving it. Obviously, you can change that through the different parameters that are located within that. If we wanted to go in and change a different parameter, we could do that. We'd hit the return button here, and that would allow us to select a parameter. But we then can go to our measuring mode. And what this does is it's going to monitor the amount of time that the tool is running for these particular fasteners. And if I go ahead and run this, you can see it's giving us what those values are, and if they change, what. So this one was slightly less in milliseconds, but we can create a window that's going to be acceptable for a minimum amount of turn and a maximum amount of turn. And that's going to allow us to be able to capture fastening errors, again, that would be cross-thread type issues, because that's going to happen right at the very beginning of the rundown. We could also then detect if there's a strip fastener, because that's going to extend past the maximum amount of turn or time that's going to be allowed to be able to see that. If there is the washers aren't necessarily present, it can help. It's going to change the amount of time that is being used. And again, we can go in and we can change what that looks like for a particular program within this. And so if we go ahead and we can tell this which of those fasteners we want to use. So if we select program 2, so now that is in program number 2. We can go back to our mode. Let's go ahead and hit reset. And if we select fastener 2, you can see our time here is what we're trying to achieve by our account of 4. And if I go ahead and run the fasteners down here, it will go ahead and count that fastener. If I wanted to simulate a cross-thread event, and I just simply power the tool again, so we get a no good rundown. Our count still remains at 3, and so we have to go ahead and do that. Now, if I wanted to simulate a strip fastener, again, now we have a no torque up event, so this would be a strip fastener, and it obviously went past the millisecond rating that we're trying to achieve. And so this one was a little too long here, and that one was okay. And then our one here, and then I'll just back this up and we'll do it one more time. It's a little too much. Again. There we go. And then we had our cycle complete, and the system went ahead and reset. And so you can see that if errors are present, the system is going to alert us. It is going to give us that no good signal. And that can be also integrated with another type of alert to let the operator know, a light tree perhaps, or some other output device that would let the operator know that that fastening was not good and that they need to reattempt it. And again, we are using a count. And so depending on the number that you might need, again, we can go through and we can change which program that we would use next, and it would then use for that particular fastening profile, if you would, for a particular rundown. So it's not necessarily regarding or relying on the torque of the tool, but it's relying on the fastener profile that we are using. And so with that, that's going to kind of wrap up today's webinar. So we can go ahead and move to any type of questions that you might have regarding this product or the topic itself. And we can go ahead and look at those. So if you have any questions, feel free to pop those into the chat and we can kind of go from there. And so today, Chris, do we have any questions? Oh, looks like we're having maybe some audio issues from Chris.
Can you hear me, Dave?
I can hear you now.
All right, I was muted, sorry. Yeah, the first question we had was, when setting up a screw rundown time, do you have like a recommended number of samples to test first?
Yeah, so obviously on a thread block, I have them set just so it's easier for the demonstration. But yeah, you could run basically as many as you like, and the system is going to keep recording that. It will average out what those fastenings are. And so I guess the recommendation would be you probably want to do 10 at least, or more the better, and see what the system is presented with you, and you can go ahead and program it for whatever number you'd want the unit to use. And again, you can always go into the parameters for the minimum time and the maximum time, and you can adjust those manually as well when learning what the fastener profile looks like for that particular screw or bolt.
All right, another question we had was on the error detection. Is it based upon time and torque values, or?
So different systems are going to operate different ways. Now, for the Scout 2 that we just showed you, that primarily is going to be on runtime, and that is the Scout is communicating with the transformer as the tool clutches out. It gets a signal from that, and then it monitors the amount of time that happens. With the POSI control system and the DPC Touch, that system can work either with torque, as it is relying on a good signal back from the DC tool, as it reached its correct torque and within the parameters that are available to make sure that that fastening was good within the DC control tool. It can also work on time as well. And the DPC touch system with the posi arm can also work with the clutch tool like this. And again, it would work the exact same way, where it is a time-based type of profile. So it just depends on the actual unit that you're dealing with, but the DC, the counting function that would be within the DC control tool is going to allow you for torque. The DPC touch and the DC tool can again also work off of torque and time, or just time by itself with a clutch tool, and then the Scout works off of just time only.
All right. Another question was for like line control. Can you stop a part moving down the line if there's like a fastening error detected with this type of systems?
Yes. So that's part of the inputs and outputs that the Scout system has. It can send those signals out to either delay a part, or you could set a mid count for a part in, or it can give it a cycle complete signal to then go ahead and move another part in. So yes, that is available through the different inputs and outputs that are available through the 25-pin IO connector.
All right. Another question we have is how many screws can you count in a sequence?
In one fastener profile, you can count up to 99 for one particular program. And again, there are 8 programs that are available on the Scout itself.
All right. Another follow-up question on the error detection. Does the fastener have to already be started in the mating process, like made into the thread, or can it start when the tools? Can it start when the tools without the fastener already being mated into the thread?
So yeah, it does. So for the Scout product, it's going to be from when the trigger of the tool gets pulled and runs down. Or if you start the fastener manually and then use the tool to go ahead and run it down, you can use it both ways. I just want to make sure that obviously we're dealing with time, so that the fastener needs to be able to primarily start from the same point each time, whether you start it by hand with a few turns, or the fastener gets started from its beginning of the fastening process. That can happen with the Scout product. When we're dealing with the DC tool, that as well can be allow you to detect errors from the moment the trigger is pulled. We could also detect errors from another trigger point that happens within the actual rundown. And so there are a couple of different ways that can be that can be detected. So with the DC control tool, we can tell the system at a certain percentage of torque, start clocking the amount of turn or angle that happens, and we can measure from that particular point what a particular error might happen, or if it does, what that error is. The DC control tool is going to tell us, but that can again monitor from 2 different locations, either a point within the actual rundown itself or from the trigger pull of the tool.
All right, that's all the questions we had, Dave.
All right. Thank you very much for joining us this month. And we look forward to seeing you in our next webinar next month. And if you have any questions about this, feel free to contact us, and we'll be more than happy to get you some more information that might be more relevant to your particular application. And with that, thanks very much and have a great day.